All right, the benefit of using or viewing the intercept form is it allows you to find the x-intercepts very easily. So that's the form that allows you to find the x-intercepts. So the first thing that you should be able to do, and you should be able to do without needing to use a calculator, is to find the x-intercepts. Remember, the x-intercepts are going to be the values of x that give you a y value of 0. So I know that my y values are going to be 0 on these. And then the easy way to find this is you just set the factors equal to 0. So what value of x would give you a 0 for this first factor? What value of x would give you a 0 in this first parentheses? 3. So that's one of my x-intercepts, and what value of x would give you a 0 here? -4. So those are my two zeros, the -4 and 3. So if I ask for the lesser one, -4, the greater one, 3. Okay? And so that's what you can find, again, without using your calculator as far as the intercept form goes. And now, it is possible to find the vertex using this. The vertex is simply going to have an x-coordinate that is the average of these two x-coordinates, the two x-intercepts. So if you took -4 plus 3, that gives you a -1. Divide that by 2, you get a -1/2. That's going to be the x-coordinate for your vertex. And then if you were to plug that number into your original function, solve for the corresponding y, that would be the y-coordinate of your vertex. Like I said, just with the other, I would go ahead and use your calculator for these. So the axis of symmetry we can identify. It's x equals -1/2. It's the x-coordinate of your vertex and a vertical line through that. We can also, or when we access our calculators, we can find the y-intercept. The y-intercept is the value of y when x is 0. And then finally, the tendencies of the graph. Is this graph going to open up or down? The leading coefficient is negative, so it's going to open down. So if a is less than 0, it opens down. And then finally, the other tendency is the wider or more narrow graph than the parent graph. Here again, disregard any signs. Is 2 the value, the leading coefficient of 2 is going to be greater than 1. So the absolute value of a is greater than 1. Therefore, this is going to be a narrow, vertically stretched, or steeper graph. Okay, so let's go back in and find the vertex and y-intercept. So if we go back to the y-editor, we'll clean that up and type in this new one. You can type in the equations exactly as it appears. Again, disregard the y equals. That's already contained in the y-editor. So here's our function. If I want to view the graphing, the graph of this function, I can. Okay. And so if I want to find or confirm the vertex, I simply go F5, the Math tab, choose a maximum point. Since it opens down, my vertex is a maximum. Pick some value, some x value to the left of my vertex. Well, I assume it's going to be a -1/2. So as long as I pick a number to the left of that. So I'm going to type in -4. I'm going to type in this intercept. I hit enter. My upper bound, I'm going to type in the other x-intercept, 3. Hit enter. And so the highest point between those two values is the point -0.5, which confirms what I did by hand, and then 24.5. So I get my vertex. And again, when you write these, either write both of them as fractions or both as decimals. So I'll change this to -0.5, 24.5. All right, once I have my vertex, the last thing I need to do as far as what's left here is to solve for my y-intercept. Very easily, I can do that in this graphing window as well. Hit F5, the Math tab, choose value, which is number 1, and just evaluate. What is the value of this function when x is 0? And I get my answer, 24. So that's all the pieces that I need. Now, let's say I want to confirm my x-intercepts. I can go back to my home screen. I already have this function typed in, so I don't even need to do anything new. It's just the solve y1 of x equals to 0, and you want to find what values of x yield that, and it should confirm 3, and negative 4 are my solutions.